Hello, everybody, and welcome. It is Advent of Code still. It never stopped being Advent of Code. So I'm quite excited to be back, and I hope that you are just as excited. So hello, everybody. It is day 5, and maybe as you can tell, we renamed a couple of the streams to give you a couple of hints about what might be happening in those particular streams. So if you haven't checked yet, you might very easily notice that each day is something special. It's something new. It's something different. That's exactly why we do Advent of Code. To try something new. And, you know, see a little bit of Kotlin code here and there. How is everybody today? How did you feel about today's puzzle? Confident? Did it work out well? Did anything throw you for a loop? I had to solve today's task on a phone. Now that is interesting. That's definitely a setup I've not used. What is today's mug? This mug comes from the wonderful city of Paris. It is the Centre Pompidou, which is a modern art museum, I believe. I believe that's the right classification. I did visit it. I'm just not that good with terminology. Naming is hard and such. But yeah, it's a gorgeous building. It has all of these like tubes on the outside that you can like actually walk up. Like the escalators run on the outside of the building, but they're enclosed in glass or plexiglass, which makes it look like you're part of a industrial like pipeline or something, like an assembly line, that kind of thing. Just finished the second task. Congrats on great time today. Oh. Felt like today was easier as well compared to yesterday. Okay, all right. So we're overall getting that feeling. I hated today's part 2, and now that one I think is going to be interesting because we'll of course also dive into this ourselves a little bit today. I'm gonna see how it goes. Today wasn't completely easy for me. Hey, I can 100% understand that. I tried to be clever and I tried to be cheeky in my solution at first, which is one of those scenarios where it works really, really well for like the tiny data set that you get for like the example input. But it does not work very well anymore when all of a sudden all the lists are like 10,000 elements long, and you know all the input strings happen to be a couple of hundreds of things. I loved part 2. 2 lines of code. Oh, interesting. Comparators are your friend for part 2. I feel like a lot. Okay, I'll be quite honest with you. I feel like a lot of you folks probably have a more idiomatic solution than I do. I'm very slowly starting to realize that. But hey, that's also part of the game. So we'll see. I do have a solution that terminates fine. My solution ran in 7 milliseconds. I don't like the code I wrote. Mine is like 58 milliseconds. Yeah. I'm sure I'm not the only person to reinvent the bubble sort today. Oh, interesting. There's a lot of foreshadowing going on here. People reusing things in part 2. So that's going to be quite exciting. We'll see what all of that looks like in just a second. So with that, I think we can start taking a look at the most important part of all of this. I mean, which is the title. If you haven't checked out the title yet, there's a little bit of foreshadowing of what might just happen in just a little bit, which is we're gonna be doing Kotlin notebooks today, and we'll bring on the perfect guest for this in a moment, in just a little bit. Still chilling backstage, because first I want to make sure that all of you know about the big campaign that we are running around Advent of Code. If you're still tuning in at this point, I'm pretty sure you've probably heard this spiel a couple of times, but there are tons of things that are happening. There are leaderboards. There are options to just, compete for the highest performers. There's options to just get some prizes by joining the leaderboards. You can tag your Advent of Code repository using the AOC 2024 in Kotlin topic, which, as we can see, is now already up to 766 public repositories. So if you haven't done that yet, make sure you do it, because the moment you solved 3 puzzles and we have a way of contacting you, you are eligible to win some exclusive Advent of Code prizes. And of course, this is a great way to find the Advent of Code template and so on as well. Awesome. Very nice. So with that, I think we can actually start and introduce our guest. He is a recurring guest, and I am very excited to have him on the show today. It's Roman Belov of Kotlin Notebooks fame. He's been here before. He's been doing some cool visualizations. It's good to have you back, Roman.
Thank you a lot. Thank you. Thank you for having me today.
How are you doing? How's the feeling about Advent of Code these days?
Well, it's always a kind of a festival for me. Actually, I've participated in Advent of Code since the first Advent of Code, and back in I can't recall, probably 2015 or something like this.
2015.
We actually it was like the first Advent of Code, and when I noticed it, I understood. Wow, it was so cool adventure. So we directly on the 1st of December, we integrated Kotlin Playground with Advent of Code, and made a kind of seamless integration. So you can there was some template or something. I can't recall it basically, but it was really nice. So Kotlin is with Advent of Code since the very beginning.
Wow, that's genuinely amazing.
Yeah, so yeah, I do like it.
And of course, we are very excited to also be sponsors of Advent of Code. That's right. JetBrains is sponsoring Advent of Code this year, just like the previous years, which is why my name has the little sponsor badge behind it as well, as you can see it up here in the corner. The Advent of Code plus part, that one I paid for with my own money. And of course, there's a little shout out to all of you. If you like Advent of Code and you want to support it, make sure you, if you can afford it, make sure you purchase an Advent of Code plus subscription. I don't know how to call it. Just make sure you contribute to Advent of Code as well, to make sure that this campaign will be able to run for much longer. All right. Cool. Well, Roman, I'm sure everybody is itching to find out what today's puzzle is, and more importantly, how Kotlin Notebooks and the solution for this puzzle are all going to work together. So without further ado, I'm actually just going to straight up put on the reading hat. Gonna make sure we stick with the tradition here.
Seb, why it's called Advent of C++ but not Advent of Kotlin?
That's a real good question. I think the it's just the increment operator, it's highlighted here. I think it's, but Advent of Kotlin, I think maybe we need to get a Chrome plugin that changes this. I feel like that should be possible to do.
Probably. Or probably C++ paid more than Kotlin for sponsoring them.
Maybe. If anyone here is extra bored and looking for a challenge, if you have like a Tamper Monkey user script that you want to build that rewrites the C++ up here into Kotlin, I would probably run that after looking that it doesn't have any encrypted payloads in it. So that might be interesting. Okay, so we are diving into today's challenge with day 5, print queue. Satisfied with their search on series, the squadron of scholars suggests subsequently scanning the stationary stacks of Subbasement 17. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The very familiar printer coming from 2017 day 1. The elf must recognize you because they waste no time explaining that the new Slay launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but can't figure out whether each update has the pages in the right order. For example, we have a bunch of rules following the orders, and we have a bunch of updates, which in this case are 1, 2, 3, 4, 5 elements long. The first section specifies the page ordering rules, 1 per line. The first rule, 47 and 53, means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be between them. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update, 75, 47, 61, 53, 29, means that the update consists of page numbers 75, 47, 61, 53, and 29. To get the printers going as soon as possible, start by identifying which updates are already in the right order. In the above example, the first update, 75, 47, 61, 53, 29, is in the right order. 75 is correctly first because there are rules that put each other page after it. 75, 47, 75, 61, 75, 53, and 75, 29. 47 is correctly second because 75 must be before it, 75, 47, and every other page must be after it according to 47, 61, 47, 53, and 47, 29. 61 is correctly in the middle because 75 and 47 are before it, with 75, 61, and 47, 61, and 53 and 29 are after it for 61, 53, and 61, 29. We're almost through. 53 is correctly fourth because it is before page number 29. 53, 29. And 29 is the only page left, and so is correctly last. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. The second and third updates are also in the correct order according to the rules. Like the first update, they also do not include every page number, and so only some of the ordering rules apply. Within each update, the ordering rules that involve missing page numbers are not used. The fourth update, 75, 97, 47, 61, 53, is not in the correct order because it would print 75 before 97, which violates the rule 97, 75. The fifth update is also not in the correct order since it also breaks one of the rules, and likewise for one more. For some reason, the elves also need to know the middle page number of each update being printed. Because you are currently only printing the correctly ordered updates, you will need to find the middle page number of each correctly ordered update. In the above example, the correctly ordered updates are 75, 47, 61, 53, 29, makes it 61. And then for the next ones, 53 and 29. These have middle page numbers of 61, 53, and 29 respectively. Adding these page numbers together gives us 143. Of course, you'll need to be careful. The actual list of page ordering rules is bigger and more complicated than the above example. Determine which updates are already in the correct order. What do you get if you add up the middle page number from those correctly ordered updates? That was a lot of text. Woof. And at that, I feel a little bit like one of those like auctioneers who auctions away cattle just by rattling off numbers. 75, 47, 61, 53, 29. That's quite something. Roman, did you have an immediate thought when you read all of this? Besides, my lord, that's a lot of text.
Well, my immediate thought is that it's a lot of text. Basically, it's really too sophisticated to actually understand what's going on. And yeah, probably, I don't know, probably it should be every time there is some ordering, there should be some sorting, right? So we should to sort something, I don't know, or something like this. No. Let's see.
Okay, so I'm just going to throw it over here on the stream to your screen, and we can take it from there. All right, that screen is up. Let's see.
Well, first of all, I've actually read the comments to the previous parts. And one of the comment was it's not that interesting if the guest showing the well-prepared solution. And it's better if it's kind of on-site solving. That's exactly what we're going to do today. So you see, I didn't submit anything. Yeah, let's see how it's going to work. So before we start, no, actually, let's start. Let's jump into IntelliJ IDEA. And in IntelliJ IDEA, I've created a absolutely fresh Advent of Code 2024 project. And frankly, I will not use it at all.
Okay.
So, the thing is that, yeah, let's start with Kotlin notebooks. I'm not sure, how many people have heard about Kotlin notebooks before. Actually, last year, also, I think 5th of December, so the 5th day of the Advent of Code, I was in your stream, and we were making some fun coding with lots of visualizations for the 5th day. So let's try to do basically the same today, but let me think. So first of all, let me show what is okay. Who actually use Kotlin notebooks? Type something like plus in comments or something, just so I understand how many people actually know what it's all about.
We'll have a slight delay, but I'm sure people are gonna head on over here in just a second.
1, 2, 3.
Look at that.
3 people out of 60. So, okay, then I'm gonna try to explain from the very beginning. So Kotlin notebooks, actually it's a plugin. Currently it's a plugin for IntelliJ IDEA, but we have a strong intention to provide it out of the box. So you can install it in the settings like any other plugin. So here it is. It's already installed on my IntelliJ IDEA, probably the recent one, but like doesn't matter. Here it is. Okay, so as soon as you have Kotlin notebook plugin, you have an option to create a Kotlin notebook. So it's actually like new, and here we have Kotlin notebook, the last one in the list. And I can give it some name, for example, day 5, and here we are. We have it in the our project. And Kotlin notebook, essentially, it's like a very cool console. So you can, for example, like execute any code, define some variables, redefine these variables, use these variables, and so on. So it's like pretty much like Jupyter Notebook, if you know what it is, but for Kotlin. In most cases, like sometimes I actually create notebooks here in the project view, and then I can actually commit them and look at them at GitHub. Or, for example, I can create a gist from notebook, and here we are. We actually have this notebook.
Wow.
Right on GitHub. And but like in most cases, when you want to create something like small, notebooks are basically just for me, it's like a small Scratch file. So like you have an option to create it in Scratch. So I click Command-Shift-N, and here's an option for Kotlin Notebook. So here we are. And oh, actually, you see, like I have a lot of notebooks created before. So I'm gonna close it, and here we are. We are in the notebook. The first thing I want to do here, I actually just want to show you like some cool stuff that notebooks actually can do. And like speaking about Advent of Code, let's probably take a look how it works with the HTTP client. You may wonder why we need an HTTP client. Just a bit of patience. So to add some dependency, you can actually just write this use and cater client, and use and the name of the library. So here we like edit cater client, and now I can, for example, I have this HTTP, and I can make a GET request. And I actually want to make a GET request to my day 5 web page. So let's do it. And here we are. Let's take a look how it looks like. It's actually HTML.
All right.
So, and here I can actually, for example, make it like this, like, and use HTML function. Nope. Oh, HTML. Okay, just like HTML. It. So here we are. We actually downloaded this page right in the notebooks.
That's pretty darn smooth. Okay, that's a good demo.
Next, I wanted to actually download my input as well. So let's get your puzzle input. Let's take this thing and put it here. But it seems like I'm missing like authentication part.
Mm-hmm.
So the authentication, I actually then went to the like, there's no API for Advent of Code. And the authentication part is actually made via cookies. So, for example, here I can change the default request. Okay, I'll make my special version of this client, call it advent of code. And here I need to add a header with special cookie, which is my
Should this be shown on stream?
yeah, it's okay. I mean, like, I don't care. If you're gonna submit some solutions for me, no problem. So
Okay.
let's take a look at the cookies. I wonder if I'm actually, like, let's say if I have it here. Where's my, oh yeah, here we are. Session, that's basically the cookie I want to use. So, and actually that, oh, I wanted to copy it. So I've copied here. Yeah, I'm sharing cookies online. And header is, what should it be? Okay, it's probably like this. No, I actually forgotten how to add cookies in. I need some documentation locator.
I thought that's what it looked like, but
should be like something. I remember that should be very, very simple. Okay, I'll take just a look how
I think
actually...
the header I think is cookie singular. Oh, it is cookie singular, and then you do name equals value, so it should be session equals.
Oh yeah. You're right. Session equal. Yeah, so it should be like this. Yeah, done it.
Okay.
So, and I don't need now this thing, so because it's already a text, right? So, and then you can imagine that you can actually not only take your input, but also take your, like, submit your output and all this kind of stuff. And I wanted to showcase it to you like this way. But it's appeared that actually there are like a lot of folks who actually already like use Kotlin notebooks. And I stumbled upon this wonderful repository, which is called Embed of Kotlin Notebook. And actually it's appeared that there is already a way to do it like way simpler. So instead of doing all of this, I just say advent of code. And now I have this advent of code client, and it can initialize it from environment variable, so you don't see my cookie anymore. And let's do it, and let's say, oh, it's not specified, so specify it here. And actually, like, I can specify environment variables right here and the property, so it should be AOC token, and let's copy it again. Copy it here. Great. So, and probably now I have to restart my notebook, so it like has this environment variable. Cool, now it works. So I can now take, for example, day 25 today and call it today. And now on this today thing, I can actually have everything, like, for example, part 1, or my, oops, something has happened, input, and so on. So there is already a library for this. So starting from today, you don't actually need to use browser for working with Kotlin notebooks. to work and to play with Advent of Code. So big shout out to author, which is Toldoven. I've actually reached out to him a few days ago so he submit the library to the so it's available this way. Actually, like if it's not, it can be like used like let me find it. So it's published, so you can just like do it like this. So you actually can mention any library and use it as a dependency in the Kotlin notebook. So Kotlin notebook actually self-contained in terms of the dependencies. So, and yep, here we are. So we actually now have, okay, let's now we can actually start our task. Are you here?
Yeah, that was pretty. Again, like I'm in awe because all of this so far, I'm getting a lot of new impressions here. Okay, I didn't know all of this was possible.
Okay, so now in our notebook we have our task, and what also I actually need my. Let's do it this way. Like for example, today input. I like postfixing and input. Great. Okay. So let's now parse the input. It seems it contains of two parts. Okay, probably like for now as an input, I'm gonna use the one from the example, just because it's way shorter, and it will be easier to understand what's going on. Okay. Oops. Copy and paste it as a multi-line string. Cool. We actually now have the input string. Great. So let's now pass it. So now, for example, what should we? It contains of two parts. So let's have rules, right? So it's input. How it's called, substring before, and something like this, right? So let's see, and I'm gonna have look at what is rules. Yep, now it's correctly what I wanted. So then I can take lines, looks perfect. Then I need to somehow parse it, and I'm gonna do something like, I don't know, like map from and to, and I split it based on this, right? And
correct.
Is it possible to return from a true, like right from here? Nope, right? That's a pity that the structure doesn't work this way.
Yeah, I think there's no other way than doing this.
Okay, so yeah, now I see it. Like, and probably here we need to also map, and let's convert it to integer. Great. Now we parse our rules. Cool story is that you can do it iteratively, so you can actually see how it goes and run the same cell more and more and more. Actually, to run the cell, by the way, I use Control-Enter, so I can rerun it and see what's going on. Okay, now I also
fast as well.
Now I need pages, or like how to call it, updates, right? Updates, which is input substring after, the same thing. Let's okay, yep, it works. Then lines, It's also work. And then map each one. It should be split based on this separator, right?
That's
Cool.
right.
We are done. Okay, so let's now analyze what's going on. So we have a number of rules, and rules are actually like setting some order. Would it be cool to actually analyze and understand what kind of order and like how it all looks like? And speaking about visualizations, let's try to draw it somehow, right? So in my understanding, each like it looks like a graph problem, right? So you can actually call each page a vertex, and then you have a number of edges between the vertices, which sets the order. So to draw a graph, I found this wonderful library, which is called, for some reason, it's called not the way how it's called. It's called Kotlin graph. But it has the different. So I just copy this address and let's use it in Kotlin notebooks. So to use any library, you can actually just like make it this way.
That's amazing.
I actually know that it has a like next version. And let's first try to copy something. For example, okay, label it graph A, B, C, D, E. Let's see how it's gonna look like. The problem is that for some reason, oh, probably it should be a GVM version of it. Let's, yeah. And this time it looks very slow, I don't know, but let's draw some graph. And it's actually pretty funny stuff. I mean, like you can, for example, okay, let's take a number of graphs. And then you actually can like, not just like draw them, but you can, for example, like you have some operators on them. And like something like this. So let's try to, okay, let's delete all our intermediate stuff. And let's try to do it like so. It's called label it graph. And here we just for each okay, rule in rules, we can like add rule first, rule second, and it doesn't work. Why? Oh, okay, because it's actually expecting it, so it's actually strings. So that's pretty strange, to be honest. API. Oh, it works. So we have actually like kind of like direct acyclic graph, right? So it actually gives you some order, right?
Yep.
The question is basically, and now is the problem. Like, if in my like actual real input, will it be possible to build this acyclic graph or not? Because, you know, like not every set of rules give you ability to build a cyclic graph. Why so? Like basically because it could be a cycle, right?
Yep.
So, and if there is a cycle, then we are kind of like we actually need to think again. Okay, let's take a look now on our original input. So where's my input? Input gonna be this one. And and we're gonna run these two.
Oh, so you
Okay,
can just skip the execution of one of the cells where you have your test input here. You can just that's very nice.
Of course. Like you like actually I've just skipped this cell which changed my input. But it's like not really good way. Like before you publish your notebook, it would be great to delete this cell, because otherwise, if someone run it from first cell to the last cell, it's gonna be kind of a problem, right? So let's see. So I actually want to do it like for a whole graph, and it works too long. I don't know what's inside this library. Yeah,
it's doing a lot of work. I mean, it's a lot of nodes, right?
Yeah, so it tries to do something, but okay, and it fails with some exception that not enough memory on the renderer.
Okay.
So it's even on front end. So like something goes wrong, and it would be interesting to understand what. So let's take on our rules. Let's take a look at them. And okay, we can't build the graph right now. Okay, let's probably build the matrix of adjacency matrix is called.
Yeah, okay.
Yeah. So let's kind of try to draw it out of the box. So like we actually can draw on any bitmap, like buffered image, for instance, and Notebook will show it. I actually don't remember how to draw on bitmap, so I'll just use AI for it. I don't know if it's allowed for our competition.
Well, you're not competing in the leaderboards anymore, and this is not exactly problem-solving code yet. So we'll allow it here, but of course it goes out to all of you. Don't use LLMs if you're competing for the leaderboard spots.
Okay, so let's ask draw rules as a matrix where first is X and second is Y as a buffered image, or probably on a buffered image. And yeah, I have some I'm not sure, yeah, image. It I don't need all of this. Just gonna use this one, and let's run it. Oh, it draws it. Basically, it draws it. Can it be okay? Let's probably, because it's too small to understand what's going on. So as rectangles of size 5. Okay, not rectangles, squares. Yeah, let's see how it works. I don't know. The result, it's always fun. Yep, we got it. So, okay, then I can actually accept and run it. No, it for some reason didn't take my edit. So anyway, so here's our adjacency matrix. Seb, what can you say looking at this adjacency matrix?
Why do you do this to me? What can you say?
Oh, well, the first thing which I clearly can see that there are not so many rules. I mean, if it's a good adjacency for topological sort, then there should be rules with almost no output edges.
First of all, are the black squares adjacent or are the white squares adjacent?
Black.
Okay.
Black
Alright.
squares are adjacent. So, and it looks like okay, let's make a experiment. So it looks like if I group it and count it, yeah, it looks like every single page has exactly 24 adjustments. I don't know why, but
that's an interesting pattern.
and what about second? And every single page has exactly 24 which are referring to it. That's pretty strange. How many, by the way, how many pages at all? Like, I mean, like rules, map it first. And how to calculate distinct count 49. So it's actually exactly a half, 24, like almost a half. What a wonderful input. But what we can say now for sure, that topological sorting is impossible here. Like, because if it's topological sorting, if topological sorting is possible, then there will be like one vertex that has only input vertices.
Okay,
and
yeah, that makes sense.
It's going to be kind of the last one, right?
Mm-hmm.
And if there are like no such vertices, then it's kind of impossible.
Yeah,
that's
okay. That makes a lot of sense because we just will if we have an like A, B, B, C, and then C, A again, you just have a loop. So you can't reasonably have all of them be before each other and satisfy that constraint.
So from this, we actually can make a very important outcome, right? So we understand now that topological sort, probably, we are not sure about it, is possible only for rules which are applicable for each line.
Mm-hmm. Yeah.
Let's try to check it. So for instance, here we can actually filter, and let's filter only the rules. So it second in updates 0 set. What's wrong with it? Filter its second in required boolean. In is not boolean.
This might be a parenthesis issue.
Probably. No. But what kind of parenthesis? You mean like this? Nope. That's strange.
Hold on.
It's second. Okay, first of all, let's start with first. But anyway, we need to be mapped.
Oh, right. Oh, yeah. Okay, this is the problem that some people shouted out beforehand. The updates one is missing a cast.
Yeah. Got it. Map it to integer. Yep. Now it should work. Yep, it works. And actually, we also need the ones that so great when so many people look at you and can help. Second. Whoa.
Okay.
Probably there is a reason. Actually, and funny thing that this library actually do a topo sorting for us. So I mean, now they like kind of topo sorted as far as I can see. Yeah, that's funny. We actually can let's probably okay. And what if it's for the first one, for example? And Why so long? Definitely not very effective. Yep. Looks weird, but it works. So great. It basically means that the topological sorting looks like it's possible. Like, I don't know, like let's take tens, for instance. And voila, yeah, it works. The graphs look really wild, but it works. Okay, so let's then understand what should we do for the solution. So we actually can now try to okay, let's copy and paste this thing, and okay, this thing, yeah. So let's solve it for the first line. So for the first line, it's gonna be, let's call it local rules, and local rules, it's just like this, and yeah, way shorter list of them. And now we need actually to write some topological sorting on these rules, so we now can understand the real order of these pages, right?
Mm-hmm.
So okay, so let's I actually know a few algorithms for topological sorting. Which one you prefer? We can write algorithm of Khan, which is basically trying to executing every time we take a let's find it. Okay, now we have a picture. So we gonna just take first find the one the vertex which has only input edges, then we remove it, then we're gonna find another one that has only input edges and so on, and then we're gonna actually get the order. Or we can write some more sophisticated algorithm, which is algorithm of Tarjan. Tarjan has a completely different approach here. He's suggested to have a depth first search. So you can actually take some vectors, and then you go along the edges, and then you actually just take the edges in the order when you exit from depth first search, DFS.
Well, which one do you prefer?
Well, the first one is definitely easy to write. Given that the numbers here are very, very small, of course, it's going to be just in time. But if Tarjan's algorithm is way faster, it's going to be basically big O from number of rules. So, but it's going to be a bit tricky to write, probably.
I mean, we can put it up to a vote in the chat, and we can see what people want. If people want streamlined or complicated.
Okay,
but
can
I just briefly give the compliment here while we're at this? You make for a magnificent guest in this advent of code, given that you just casually happen to have two algorithms that solve the same topological sort problem. And apparently are confident enough to build either of them just like that.
Well, actually, the funny story is that when I just joined JetBrains, I was working on .memory profiler, and one of the complicated algorithms that was inside is actually calculating dominators in directed graph, and dominators in memory is actually the object which dominates some memory. So when you delete this object, it's gonna delete all objects which are actually like they're gonna be garbage collected because of the it won't be impossible to reach them from garbage collection routes. Like I started to implementing another algorithm of Tarian, pretty similar to this one. And later I improved it, and still we actually, as far as I know, our code base have the like algorithm which is called like algorithm below Tarians. Below it's actually me. So and it's
That's
like
incredible.
Became fast. Okay. So let's try then to write the one which is simpler, because like probably our viewers are going to be happy that we do not complicate things when there's no need to complicate things. Okay, so basically, yeah, let's start it from the very beginning. So like first we need to create adjacency lists. In our case, because we're going to create it iteratively, it's going to be adjacency maps. So let's call it adjust. Okay, let's call it later. Or not? Okay, adjacency. Wow, it's suggesting something cool. I like it. So it's going to be a mutable map of from integer, which is number of the vertices, to mutable list of integers, right? And let's construct it. So for rule in local rules, we're gonna do the following. So we take this adjacency list, and so we actually need to what should we actually need to like either create a new mutable list of or put it here. So this should be some like shortcut for it. I mean, like let me compute. Yeah, compute if absent. Yeah, compute if absent. Rule first, and then then we mutable list of mutable list of. So simple, and in that case, we then can add rule second. And let's take a look how it looks like. Yeah, looks good, I think. Like
I think for this specific case, you could have also used get or put, which is the Kotlin version of this.
You mean like get?
Yeah, get or default. Actually, get or put also exists, yeah.
Yeah, but what to put?
Well, because, the mutable list off, the empty mutable list, right?
Ah, you mean like get or put, like this, right?
Yeah. Yes.
Yep. Also works, right?
The other one was just one of the functions from the JDK rather than the Kotlin standard library.
Yeah. You're right. So get or put, and basically now we have adjacency list. So and let's also calculate like the degree of each vertex, like not the degree, not the output degree, but input degree. So let's call it in degree, and it's going to be mutable also map of from int to int. And like here we actually need to in degree. Yeah, here we need to actually put it this way: in degree get or put, you said? No, something. Oh,
yeah.
Oops, completely wrong stuff here. Get default p0 and also +1, right? What's wrong with you?
It still takes a lambda. I think. Oh, never mind.
Oh,
it doesn't. This just types. My bad.
No, it shouldn't take lambda, I think. Yeah, so
No,
it's yeah, it has default value. So, but still something wrong here. Like, oh, why B? It's just like second, right? Rule second. Rule second. That looks pretty good. And let's take a look at in degree stuff. So I wonder why we need in degree, but like probably out degree is enough, right? So yeah, so let's call it out degree. Okay, let's rename it. So we're gonna delete out the one with the smallest number of out. And first here then. What is bothering me? Why actually here's like, oh, I see. Because the one with 0 is actually not here, right? So we actually need to out degree rule first and boot. Oh no, the boot if absent rule first. 0. Nope, still doesn't work. What's wrong here? Like, what I'm expecting, there should be one without degree 0, right?
Mm-hmm.
And
that rule second on line 5.
No.
That one's fine.
No. Yeah.
Okay.
It should be like
then...
this.
Okay.
Yeah,
oh, there's one with 0. Nice.
Yeah, now we have it. Cool. So like we actually now calculated all the degrees and we now like write the algorithm, right? What I like about notebooks is that you can always iterate through and see what's going on and like understand if there is an error as soon as possible, which is really nice and error-prone way of writing code. Okay, so let's have some view of integers, and let's initialize it for like with the in it's now called out degree. Like, and if we, okay, probably better do it this way. Filter, and it value is 0 for. Is there like something like, for example, to Q or something? Okay, to set gonna be just fine.
I don't think we have to array deck. That would be nice. But I think array deck does take just a list as a as a parameter, so you can use the like constructor function.
Yeah, we actually can just like make something like to mutable list. Actually, I think it not really matters here. Like, okay, we have a queue, and it's now should contain, yeah, just probably here we need also add some mapping function, right? So it key. What's wrong with you?
Well, it's just a key now, so it no longer is a map. It's just a value now.
Oh, to list, to mutable list. Nice. So now we have a function like a vertex to basically delete, like to extract it. Yeah. So and finally we need to write a algorithm itself. So what we're going to do, we're actually going to take this take it, and we need to remove these edges from all adjacency lists, right? So like edges to 87. So the good question is how to do it efficiently. I think we're going to do it like then this way. We just invert our adjacency list from the very beginning. So we actually put it this way: second and first. So now it's like input input edges, and the queue is the same, but now we like for our like let's take adjacency list from queue first. We have a number of edges to remove. Actually, let's draw it for the chart so we can verify that we do the correct thing. $89, right? And we have a number of edges. You see, like we see only 3 here, but actually, like because there are a lot of splits, there are a lot of more than just 3. So we see lots of them here. Great. So now we actually finally can write our algorithm. So it should be something like while queue is not empty, we say like while vertex is queue remove first, and then let's also like for now, like let's create something like result, which is mutable list of int, and it's empty, and we add result. Oh, I didn't run it. Result at vertex, and now we need to remove, and for every vertex which is in adjacency list, for E in adjacency list of vertex. What's wrong here? non-nullable value. Okay. Get. Okay, I'll probably just like do it this way because we know it's correct. And or we actually can do it like, okay, in a safe way, right? So put it empty list here. And out degree of v should be out degree of v minus minus. Okay. Okay, what's wrong here?
Has to be -1, right?
Yeah, you're right. So, and yeah, if after that our degree of v is 0, we have to add it into Q. You add v. And looks like that's basically what we need.
In line 5, you still have a couple of extra brands on your empty list. Yeah.
Here we are. 89, 83, 26. Let's see. 23, 26, 72, 92, 37, 72, 92, 37, and the first one is 38. Wow, we did it.
Wow, okay.
So it works. So, and it works for one line. So now we need to take this local update is updates. For now it's 0, right? And we need to sort it by, and now we need to use this index for sorting, right? So, oh no, we need to check that everything is okay. Yeah, we need to check. So we need to check that all let me think. So we actually need to make a map of it, right? So like we're gonna make a wall index as a result. Is there indexed? Map indexed? No, it's like, okay, it's an order. So we now need to check what we need to check. So we need to Seb, I need your help here.
There's an interesting point that's being made, which is we can just compare the results with equals, but I think it's not the case, right? Because topological sort, we may have more than one order.
Yeah, of course. We yes. May have more than one order. It depends on number of.
If we have any elements that don't participate as well, I guess they can just be in any given.
Yeah, we can't like use index for this.
Okay.
So we need actually to like to create a comparator. So no, comparator is not enough, right? So we need to verify that no rules are broken, right?
Mm-hmm.
So let me check. So yeah, so in that
good
regard,
functional paradigm is hard for this for me. But I mean, I guess otherwise you can just once again treat them as a queue, and whenever you encounter one of them, pop them off the stack. And if you go through the entire list and your queue happens to be empty, I think that means you have a correct ordering.
I think, well, it's one of the approaches, or so we need to verify, like, okay, sorting. Oh gosh, it looks like sorting is not enough, right? I mean, like, it's like, even that we now have a topological sort, but it's not enough to check if no rules are broken.
Actually, you can. I mean, Jelly Owl adds a good point here, which is I'm sure there's only one order per update. So can we actually just do a quick check to make sure that each element participates in a rule? Because if each element participates in a rule, then I guess it has.
Nope, it's not true.
Nope, that's also not. Yep, you're right.
You can imagine something like 1, then 2, then 1. So
yes,
it's like a square, and the order on these two are not set.
Yep, you're right.
And
that's my bad.
And we actually can't. So this it's very specific. And in that regard, it's actually a very specific task. I mean, like, topological ordering is not enough here, and actually it looks like we have to manually check anyway. But now we can make a small hack. Let's first take a look at our updates 0, right? So for example here, updates 0. So let's imagine for a second, so that you're kind of right. So I mean the order is the same. So we now surely can check just result reserved and updates, and check if they are equal. Okay, no, how to is there a function to check that two arrays are equal?
Yeah, it's dot.
Nope,
dot content equals, I think.
Oh yeah, you're right.
Or well, but you're using lists, no?
Sorry?
But you're using lists. You're not using arrays.
I have two lists, right? So, and it's is it possible to check that two lists are equal?
Yes. This should just work if they are the same.
No. You think it should?
I'm fairly certain. I mean, you could just write a.
Oh yeah, it works. Yeah, it works. Yeah, it should work. Okay, great. So basically, let's try it this way. I mean, it's a dirty hack, but why not? So we have a number of things which we calculated for update number 0. So we now gonna make funny stuff. So we actually gonna merge the cells with a buff. So for example, here we have local rules. Okay, great. Then our degree, this one I can just delete. It was something not really important. Merge cell above. Great. So we have Q. This one we just delete. This one we're gonna merge cell. And this one we're gonna merge cell above. And now we have just one cell. And it works. Which is nice, because now we actually can try to, for example, make it as a function, right? So we can, for example, write function is valid from integer or from from list. Okay, list of integers. So and call it update, and delete all of this stuff. and return it. Is it right? So
Looks right.
okay, is valid. So updates is valid. Filter is valid. Okay. And oops, sorry. Now we have some updates which are valid, and map it all to it. It's count by 2 and sum it. Cool. We have now some number. Let's try to submit it. Remember, we are still submit part 1. This one. The answer is correct. And if I would this, if I move here and actually refresh it, it works. Great. So
yeah, my mind is blown.
Now let's take part 2. Yeah, I know, like it happened very fast, like in the end.
Yeah.
And yeah, we have a part. Oh gosh, it's like, for the record, it's actually like I didn't look at it before. So part 2, what should we do here?
Well, I mean, I'll happily do the quick. I'll do the quick.
Where's your head?
Yeah, I'll do the quick reading break. I'll read it off of your screen. Absolutely. Different color scheme straight from notebooks. We are back after that amazing first solve in part 2. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are 3 incorrectly ordered updates and their correct orderings, with 75, 97, 47, 61, 53 becoming 97, 71, 47, 61, 53, and 2 others. Okay. That sounds pretty good, right?
Yep. And it looks like we can do something like this now, like follow the hands.
Aren't
we just like gonna return?
I was about to say, aren't you just kind of done?
We're gonna return a result instead of this thing. Type mismatched. Oh yeah, fix it for me, please. So now we like just returns the topological sorting. So, and now we just like, oh no, it's not only like this. It should be only for, it should be for those who are incorrectly ordered.
Yep.
Okay. So like in that regard, we made it way harder. So we call it integer then finally, and if result is not update, result reversed, like how it was originally, then return result size elsewhere in just 0. Something wrong here.
Return 0 or lift the return statement.
Sorry?
You can either write return 0 or you lift the return to the very left of the line.
You mean like this?
Yep.
Okay, That's gonna work. And then in that regard, we just like map it and sum it. And it should be like called differently, right? So like something strange. So, and we have another number. Okay, so let's submit part 2. Oh, it's also correct.
Okay.
Beautifully.
Okay, good moves all around. Wow.
Like, and yep, and I'm done. And so the last thing which I really want to do, I want to take my Advent of Code client from environment variable interactive day 2024 6. And let's try to take the next thing as well, view part 1. And it looks, nope, I can't do it. So wait until unlocked.
Okay, you are ready. That's incredible. The fact that that's part of the library is I'm having the greatest
it's not
time.
me. Shout out to the author, Toldovan. That's really nice thing.
I will add this link again.
But frankly,
yeah.
it's like just amazing way to play with Advent of Code. Like you actually, what really cool is that you actually, after you made a task, you can create a gist and click OK. And the gist is here. So you can actually share it with folks.
Wow, and it has all the executions in there as well. It has all the graphs in there as well. That is an incredible way of sharing what you've done, actually.
And actually like the task as well. So like if, for example, like 10 years after someone will find it, they will actually understand what's going on here. Otherwise, all the solutions which are available nowadays of Advent of Code in 10 years gonna be like kind of like it's gonna be completely unusable because this Advent of Code site will be definitely unavailable 10 years later.
Yeah. Wow, Maya says it quite nicely here. If you add a couple of comments in between, if you add some markdown cells, you have an instant blog post right there.
Yep, kind of.
It's just so cool.
So
truly incredible.
Very easy, and yeah, and cool story is that you actually can, like, by the way, like, I really want, you know what to do? It would be really interesting. So let's make a function from this thing. Like, let's call it function that returns buffered image. And it's gonna be like matrix from the input. We input from the, like, where is the, okay, it actually, okay, so it's actually gonna be rules, which is a list of integer, and make it this way then. Oh, it's not list of integer, but list of pairs. Integer to integer. Yep. And return image. Cool. So now I have a way to draw adjacency matrix. So now let's go to our algorithm, which is this one, and let's do it this way. So for example, here, I after on every step of the algorithm, I'm gonna draw the matrix. Gonna display the matrix, how it looks at the moment. I need to run this. What's going on? Why it's hanging? Oh, it's hanging because like this running. Got it. So now I have this matrix function, right? Oop. Where it is? Yeah. Matrix out from local rules. And local rules, I'm gonna sort by wonder how to in the currency. Okay, in the idea is to show let me show you something strange from updates 0. It's gonna draw the matrix, lots of the same matrix, and I want to actually so it shows how it animates during the while we run the algorithm.
Mm-hmm.
And the problem is that I need to draw not the local rules, but the the rules in order of the current order. So instead of probably oh no, it's gonna be complicated. Okay, doesn't matter. It's gonna take us another 10 minutes, and I think everyone already tired of this stuff. So anyway, next time.
Okay. Hey, but this is still a really exciting solution, and I actually have a teeny tiny gift for everybody who decided to tune in today. If you decide to stick around up until now, because this was really cool. So I actually managed to convince somebody somewhere that today we have a discount code for our JetBrains merchandise store. So if you're really excited about Kotlin, you want to get some Kotlin swag, you can use code AdventOfCode 2024, which is only valid for about 24 hours from now. So it's really an Advent of Code thing, and you can grab yourself some merchandise, represent Kotlin at a slightly cheaper price point. Roman, this was really amazing. I do very briefly. I'm going to take you off screen here for a sec, or your monitor off screen for a second. I'm gonna just bring up my own screen here for a second, because I do just want to spend 5 minutes showing off my solution that used much fewer brain cells, but also got me somewhere where I needed to go.
Well, obviously, you're absolutely right. I mean, my solution was a bit overcomplicated, but I wanted to show that even pretty hard algorithms can be written without any mistakes if you do it iteratively in the notebook.
Yes.
And it's
you have me convinced.
Great. So
yeah. So for part 1, okay, first of all, my parsing logic. At 6 a.m. this morning, I did not realize that I could have also just done this very nice thing where we split on a double new line. I could have remembered that from last year when something similar happened. So instead, I'm essentially just saying, okay, we'll take everything until I hit a blank line, and likewise for the updates, I'll hit anything after, or I'll hit the last thing after I've hit a blank line, which gives us the same thing. Apart from this, nothing particularly special here anymore. Okay, so for part 1, I translated it quite literally. I was like, okay, for each one of the updates, which is the bottom part of our input, if it is valid given the ordering rules that we parsed, then we want to put that middle number of that specific update into our sum. Otherwise, it does not contribute anything, so it's just 0.
How did you check the validity?
How did I check whether it's valid? Well, it's very simple. An update is valid if all the rules happen to be applicable. In this case, I'm actually doing a bunch of extra work in theory because some of the rules, of course, I might have filtered out in advance. But it's quite simple here, right? I'll figure out we have a before and after location inside each rule. And I'll just see what the index is given our specific numbers that are in the update. And if one of them just returns -1, that means the rule doesn't apply. So we're definitely okay. That single rule doesn't apply. Otherwise, as long as the before location is the index of the element that's specified in before is lower than the index of the element that's specified as after in the rule, that means the single rule is valid. And that's how I solved part 1. It was essentially just a bunch of index lookups and a bunch of all and count queries. No tuple sort here. Thoughts so far?
I think there was a comment or something like, let me find it. Where it was like, it's something like, why do tuple sort? And it's actually like they were suggesting just for fun. Yes, it was just for fun.
Clearly. Well, it did come to mind in the morning, but I did also just watch you implement it, and I can tell you that at 6 a.m. before breakfast, I think even with Kotlin notebooks, it would have been a stretch for me to implement that, or that would have taken a minute. But yeah, so this is the very silly version of doing this. Then the second part required me to figure out if things are in the correct order. So we already know which ones of them are invalid from part 1. So we can just do that filtering using the exact same stuff. And then we just want to sum up all the middle numbers of things that happen to be better updates. I'll be honest with you. My first initial thought, and something that works very well if you're just looking at the test input, is I was like, I'm just going to see if I can cheat this. I'm going to see if I can try to be sneaky. And I was just like, you know what? We're just going to shuffle this list. And we're going to see if all the if everything's valid, if all the rules apply, then we're fine. This works great when you have like 4 numbers and like your rule set is like 10 rules in total. It's not so great anymore when your input looks like this and the length of your updates is this long. So that very quickly went out the window. But hey, I had to try because I was like, if it works, that's gonna even if it runs for like 20 seconds, that's gonna give me a better time than me trying to be clever about it. So then I figured, okay, well, all that we need to do, if we kind of look at it, is we need to, whenever there's a rule violation, we can fix the rule violation by flipping the 2 elements that are violating that rule, which is my produce a partially better update function. Which again is just, okay, first of all, if a given single rule is valid, we don't care about that rule. If we have a rule that's offending, then we will just swap the 2 elements. So we'll figure out where they are and we'll just write into their locations. So we'll just do a swap. We'll create a new one. I have a little assertion in here because we've only fixed a single rule, but it should actually be correct at this point. Here, I'm just returning that new update. I'm doing a single swap, and then I'm just returning it. which is not particularly efficient because I have like an entire like remaining rule set I might as well still like work on rather than going back out. But this works. This is fine. So once I've done an individual swap based on the entire rule set, I just do that until I no longer can make any changes, or in other words, until I no longer have anything that requires a rule violation to be fixed. It's just an update that is entirely better. It's totally better in every single way. Yep, and then when you run that, you get your two values. The first part runs in 9-point-something milliseconds. The second part runs in like 60 milliseconds. It does work, and there's optimization potential. But yeah, I'm also seeing a lot of people saying that they used a comparator. So very nice. We have a couple of different approaches. Maya says,
actually, comparator doesn't work in this case. I think. Like, I mean, like the comparator, the main like kind of advantage, like no, the main requirement for the comparator gonna be that it should be applied to any pair. So for some pairs, you can't apply it. That's basically the main problem.
Mm-hmm.
To be honest, like there are like a lot of other problems. Like potentially, it's all is not really that valid because again, topological sorting could be different. So the middle number potentially can be also be different. So there are lots of preconditions in these tasks which are actually not in the task. So
that's actually a super valid point. Now that you mention it, you're right, because if the middle number just happens to be on one of the paths of your topological sort that has one of those forks inside, it's no longer. Well, I mean, you also don't. To be fair, you also don't know. Okay, they are hard coded. You have a singular final number. I was like, they could just check on the server side and they could allow you like 3 different solutions. Each one of them would be okay. But I guess they don't do that.
Yeah. So, like, actually, when you're preparing such tasks, it's the hardest part is actually to prepare the input, because you have to think about all of this stuff.
Yeah.
Otherwise, like, if for example you create it just literally using some random generator, it won't work. So it's gonna be like, and there are going to be a lot of complaints like, why? It seems my solution is completely correct, and so on and so on. And like, that's why I've started with analyzing what's inside. And actually, the reason why it's 49 and 24 is that if you have exactly 24, then there's no chance that that they're going to be forks. And it's actually not that hard to prove it.
Oh, okay.
So it's, yeah, they actually very, very, very tricky. I mean, like, it's pretty well prepared task, I would say. So
I very much also like, yeah, AOC is all about, well, it's not even cheating, but yeah, you just look at you stare at the input for a long time, and you figure out what kind of constraints happen to hold for the input, and that can kind of give you an edge that otherwise you might not have.
You actually, like, in your case, you invented kind of like semi-bubble sort, right? So you just like bubbling it until it's okay. And the problem is that potentially it just like, oh wow, there is a chance that it won't stop. So it won't stop. It will never stop. But like, again, it all depends on number of rules and the way how you applied them. But yeah, that's totally great solution. I completely agree, especially given that you get the final number and it's correct.
Yeah, that's the most important part about all of it. I was also very excited to to get it. I see a lot of people saying here, I think Mr. Vastel made sure to not let that happen to us with the middle numbers. And yeah, Mr. Vastel give us a break. So if you're not, you probably picked up by who we're talking about here. But since we're kind of wrapping up here, I do want to send you to one other thing that you can watch right now, because Eric Wastel gave a keynote speech just a couple days ago at CPP North, which is about Advent of Code behind the scenes. You can see that this is one of the events that was also sponsored by JetBrains. And it's Eric talking a lot about what goes into creating the puzzles, how to structure things, what kind of strange access patterns AWS can't really deal with, because as it turns out, it's kind of hard dealing with a whole bunch of people all logging on at midnight or 6 a.m. or wherever. And trying to prepare for that, which is quite hard. So I'm going to post that one in the chat as well. So maybe take a look at that if you haven't had enough of Advent of Code for today. And of course, one last time, I'm also going to post the Advent of Code 2024 discount code if you would like to purchase something there. Apart from this, Roman, thank you so much for coming on today and solving this. I think I speak for every single person who's watched this stream. I've learned something new today in so many different ways.
Thank you very much for having me. It's always a great pleasure to me to participate in your streams.
I really, really appreciate it. So thank you to everybody who decided to tune in at home today. And of course, if you are still as excited as we all are about Advent of Code, make sure you tune in for the next days. Make sure you hit those notify me buttons to get a notification. And of course, make sure you do not miss tomorrow, because tomorrow is Advent of Code 2024 in Kotlin Office Edition. That's right. It's going to be a little bit of a different location. I'm not going to be filming alone either there, so it's going to be a great time. So come on back tomorrow at the usual hour, and we're going to solve another puzzle. It's going to be exciting. Take care, everybody. Have a good night. Bye-bye.